All right, so I got these 6 attachments.
Mm-hmm.
We want to start with this one here.
Mm-hmm.
Okay. So there's the hard way and the easy way to do this. Since they ask for y0, let's start with that. First of all, let me label some things here. This is 3 ey. OB is 4. What's E? Excuse me. What is YO?
Oh, 5.
Right. So that's 5. Now, what's EO?
That's 13.
Yeah. But that is still the hard way to do it. When you have a rectangular solid, the diagonal from one vertice to the opposite vertice is the square root of this. It's kind of like the Pythagorean Theorem, only in 3 dimensions. You might think it would be the cube root of everything cubed, but it isn't. It's the square root of everything squared. So let's see if we get 13 by doing it that way. Well, we know the 3 dimensions are 3 squared plus 4 squared plus 12 squared. So that's the square root of 9 plus 16 plus 144. That's the square root of 169, which is 13. But you can see that that's doing it in one step. You do not have to break it down into these 2 triangles, ever. In other words, whenever they give you a rectangular solid, so on number 2, what's the diagonal going to be?
5 square root 2.
You're ahead of me. Okay. All right. Let's go to the next page. If you've already done some of these, let me know, and we don't need to do them. What is the next page? It must be this one right here. Yeah.
Yeah.
Yeah, no, if you've done some of these already and you know exactly how to do it, then let's not waste the time.
Mm-hmm.
But that's fine. We can just go over them. Interrupt me if I start to go over one that you know how to do. All right, so this is a regular square pyramid with a slant height, AF. Notice the slant height is always the bisector. In other words, it's not AB. It's kind of like an apothem. You know what an apothem is?
No.
No, not yet. Well, you can see AF is a bisector of that outside triangle ABE. And that's what a slant height means.
So it's like the altitude of the triangle facing.
Yeah, exactly. If you were looking at it from this angle, you'd be looking, that AF is the altitude of triangle ABE. Okay. All right, let's see what they have to say here. Perimeter of the square base is 40. What's that mean each side is?
Square base, so it'd be 10.
Okay. So that's 10, 10, 10, and 10. AFG is 60 degrees. Okay.
So it's a 60, 30, 90.
Correct. And not only that, you know that G is at the center of that square because it's a regular square pyramid. So if you drop a perpendicular from A straight down, it ends up in the center of the square. Okay. So let's look at a triangle that I'm going to draw separately. I'm going to draw it over here. This triangle is FGA. Okay, so you know which one I'm talking about?
Yes.
What's FG's measurement?
FG would be 5.
And if this is a 60, 30, 90 triangle, what's AF?
AF has to be 10.
Good, very good. Not everybody knows how to do that. And does that answer everything? Not quite. We need AG. What is AG?
AG would be, well, if we know, so it's 100 minus 25 equals 75. So square root 75. So it would be 5 square root 3.
Okay. Actually, is a better way to do those 30, 60 triangles. Let me just point it out to you because once you learn this better way, it's the only way you'll use. You won't go through the Pythagorean Theorem. That's 1. That's root 3 over 2. And that's 2. So that is always the relationship of the sides of a 30, 60 right triangle. Notice that we had 5 at the base. Well, I know that the hypotenuse is twice the base. And I know that the side is root 3 over 2. What's happening here? Let's see. If I were to multiply everything by 5, I would have 5. I would have 10. And I would have 5 root 3 over 2. That's because it's not root 3 over 2. It's root 3. All right. Sorry about that. That's not helpful when I'm trying to teach you something to show you the wrong thing. That is the relationship of a 30-60 triangle. Okay?
That's a lot faster.
Well, now I'm going to give you a different one.
Okay.
Now tell me what X and Y are.
What's the square root?
You don't need that. That's the thing. In other words, every 30-60 triangle is like that. So X is automatically half the hypotenuse. So what is X?
X is half of whatever. What's in the square root?
7.
7.
So X is root 7 over 2.
Okay.
And then Y is automatically root 3 times the base. So Y is root 21 over 2. And you're done. No Pythagorean theorem needed.
Cool.
And there are 2 triangles that you will be tested on at least 100 times over the next 3 years. That first one and this one. And it's the same concept. In other words, if you run into a 45-45 90-degree triangle, you always know that it's going to be in this proportion. The two sides will be equal because it's an isosceles triangle. But the hypotenuse will be square root of 2 times one of those sides. Okay? So it's definitely worth solving those types of triangles using this method here. And that's all you really have to do is find out the relationship of the two triangles. In other words, when I gave you this one here, and I said that was square root of 7, well, if I'm looking at big to little, the similarity ratio is square root of 7 divided by 2, right? In other words, that's how much bigger this triangle is than this triangle. 7. It's the relationship of the bigger side to that corresponding side. So everything in this triangle is multiplied by that. So this side is square root of 7 over 2 times 1. This side is square root of 7 over 2 times root 3, which is how we got our square root of 21 over 2. All right. Let's look at number 4. Have they taught you this diagonal of a solid formula?
No.
Yeah, I'm beginning to think they haven't because they keep giving you problems about it. And once you know that formula, these problems are no longer even exciting. So what is it?
So it would be square root GC.
All three sides squared. And the 3 dimensions they gave us were the 3 dimensions of that rectangular solid. So what is it? Not the final answer. How do I set it up? It's square root of what?
8, 12, and 9 squared.
Yeah, the sum of each.
144 and 81.
Yeah. Not so concerned about solving that. It might be actually interesting to solve from a simplification point of view. What do we have? We have 9, 289. That's got to be a perfect square number. That got to be 17 squared. So that is all equal to 17. Now, it's possible that they wanted you to do this, and I don't know. I mean, when you have such an obvious formula, I tend to want to use it. I stop wanting to do it the hard ways. Now, the hard way would be to draw a triangle like that and figure out the various dimensions of that triangle, starting with DB. You know what DH is, but if you can figure out DB, then HB is the diagonal of that triangle, or the hypotenuse of that triangle. But that's a lot more work, and frankly, don't see why they would even want you to do it that way. All right, let's look at number 5. PY is 24. Boy, it's even hard to label these because you have such little room. So that's 24. ID is 14, which makes each side 14, which makes that 7. All right. So what's AD?
AD is 14.
What's YR?
7.
What is PR?
PR. So that would be.
Here's that triangle. PRY. We know that YR is 7. We know that that's 24. This is actually another perfect Pythagorean triangle that you run into every now and then. It's 25. Believe it or not, you would expect it to be a bigger number, but it isn't. So that's what that is. The perimeter of the base is what?
56.
The diagonal of the base not shown. Well, we have a square base that's 14 by 14. You want that diagonal. What's that diagonal going to be?
It's going to be 19.8.
Never give it as a decimal unless they specifically ask.
So it would be...
As a radical. What is it?
1 second.
And the reason is a decimal is 100% of the time an approximation. It's not the accurate answer. It's an approximation.
So it'd be 14. Wait a second.
Well, it's 14 squared plus 14 squared, right?
Yeah.
Okay. What's 14 squared?
14 squared is...
Now, hold on. Let's do this a different way. I want to do it the way I just taught you. You can see how hard that was to do if we have to use the Pythagorean theorem, especially if we don't have a calculator. This time, I want you to do it the following way. I want you to compare it to this 45/45 of known ratios. It's 1, 1, root 2. So what's that hypotenuse real quick?
So it's going to be 14 root 2.
See why that's such a valuable way?
Yeah.
Yeah. So you always, and you get so many problems that are about 30/60 right triangles or 45/45 right triangles. Those are the two that you're going to be consumed with for 90% of the problems you get over the next 3 years. It's going to be one of those two triangles, and so having that little technique makes it a little bit easier. 6 on the next. Is that all there is to 6?
Yeah, that's it.
Find the slant height of a regular square pyramid. We'll use this as our square pyramid. Since it's already drawn, I don't want to have to redraw it. So there's a regular square pyramid up here. If the altitude is 12,
so G,
and one of the sides of the square is 10.
What does it mean by 10?
BC is 10. One of the sides of the square base. They want this slant altitude right here.
So we just need to find G, F, whatever.
What's FG?
That'd be 5.
What kind of triangle is that? 5, 12, 13. 5, 12, 13, exactly. All right. The next page, let's see, that's 92, that's 93, this is 94. we going in this order, or did we skip one?
Yeah, that's the right order.
Okay. Given circle P. Okay, what are the coordinates of E?
E would be
This point right here. It's the radius of that circle.
3, 0. Or 0, 3.
No. Give the x coordinate first.
So it'd be 3.
This over here is 3, 0.
Oh, negative 3.
Exactly.
Yeah, I was doing that wrong.
Okay. The area of the sector EPG, that sector right there. It's the quickest way to figure that out.
The quickest way?
Uh-huh. Always seek the quickest way.
Just do 9 times 3.14.
Well, 9 pi is the area, right?
Mm-hmm.
Well,
and then just divide it by 4.
There's your answer. It's not 3.14 times 9 divided by 4. It's 9 pi over 4. Again, always give exact answers if you can. Pi is an exact number. 3.14 is an approximation for it. So my apologies. I just read the directions. It says to the nearest tenth. Go ahead, substitute 3.14, and then round off your answer. Now, you don't want to substitute 3.1 for pi. You might end up with some round-off error. So substitute at least this, maybe even that. And then take your final answer and round it to the nearest tenth. So what do you get?
7.1.
Okay. Now go back and do it where you just use 3.1 and do it. See if you get a different answer.
Mm-hmm.
Try 3.1 times 9 divided by 4.
Equals 6.9.
Really? Is that big of a round-off error?
It was 7.
Well, nonetheless, it's a different answer.
Yeah.
So when they say round off to the nearest tenth, that does not mean round off pi to the nearest tenth. And in fact, the best way to do it is to do it in your calculator and use the pi key. And then you'll get an answer like 7.1428, and then it's easy to round that off to the nearest tenth.
Mm-hmm.
All right. The length of arc GE to the nearest tenth. Are you going to do this? How are we going to do this one?
Find AB. So we just need to know that.
Find what?
AB.
Where's AB?
AB is like the hypotenuse of the triangle.
No, actually not. Think of it in different terms. What's that a quarter of? The circumference of that circle. What's the circumference of the circle equal to?
3.14 times.
Well, let's leave it in pi until we get a final answer, and then we'll round off. Okay, in other words, the circumference of a circle is 2 pi r. Well, we got a radius of 3 here, so that's the way we get 6 pi. Let's leave it as 6 pi, but then this is only a quarter of it. So I got to divide that by 4. Now, put that in your calculator. 6 times pi divided by 4. Come up with an answer and then round it to the nearest tenth.
That's 4.7.
Okay. I'm actually really surprised that in honors geometry they're having you round this to the nearest tenth.
Yeah.
This might be the last time in your math career that they ask you to do that. Not today, but this year. In other words, when you get into all higher math, they never want approximations. They want precise answers. And you get that by using the radical answer or pi. All right, number 12. I guess I have all of the information, don't I?
Yeah.
Yeah, okay. Find AB.
So it would be, we know that the base is 20, and we know the height is 6.
No.
And then we just need to
hold on. Height is not 6. Height is the y coordinate.
Oh, 8.
Yes, that side's 8. What's this measurement right here? That measurement between the center of the circle and right there.
That's 6.
Okay, what is it from the center of the circle over to there?
It would be 14.
Well, it's 6 plus 10. In other words, that's going to be 10, right?
Mm-hmm.
So that whole base is 16. And since we're dealing with the Pythagorean theorem here, we're going to have to use it. In other words, we do not know what that angle is. Not without some trig. If you had trig, we'd be able to figure out that hypotenuse easy. But in this case, it is not a 30-60 right triangle, nor is it a 45-45 right triangle. Okay, and you can kind of tell just by these dimensions. Neither of those two special triangles have a relationship of 1/2 between the short side and the next shortest side.
Mm-hmm.
So, in order to get AB, we've got to use the Pythagorean theorem. What's it going to be?
It's going to be the square root of 3. Well, it's going to be 16 squared plus 8 squared.
And this time, let's leave it as a radical because he doesn't give any special instructions to do it to the nearest tenth. So that's 256 plus 64.
That's 320.
320. Now, how do we know whether we can simplify 320 or not?
I just divide it by
Anything else on here? How can you tell? When it comes to simplifying radicals. Because like I said, if you put that in your calculator, they're going to round it off to a decimal. And then you're going to have to put that down as an answer. So if we don't want to do that, if we want to give the most simplified radical, what we're looking for is factors of 320 that might be perfect square numbers.
I did 4 times 80.
What's another perfect square number? Keep going up. What's the next one after 4? 9.
8.
Right? 9 does not divide into that. What's the next one after 9?
10.
No, perfect square number.
Oh, perfect square. So 16.
Yes. 4, 9, 16, 25, 36. So we're looking for the biggest one we can find that divides into that. Well, notice 16 is exactly half of 32.
Mm-hmm.
So that's got to be the square root of 16 times the square root of 20. Well, square root of 16, that's 4 root 20. And it turns out that we still didn't find the biggest one because root 20 breaks down into root 4 times root 5. So it's actually 8 root 5. In other words, 64 divides into that perfectly, 5 times. So if I'd have listed all my perfect square numbers over here, I would have seen that 64 is actually the biggest one, and then I can do the whole thing in one step. I get to 8 root 5 immediately. Now, when you are simplifying radicals, there's no rule that says you have to do it in one step. There's not too many people I know that would realize that 320 is divisible by 64. I didn't realize it. But I did realize it was divisible by 16 because 16 is obviously half of 320. And so when you do it the slow way, which was the way I did it, you eventually get to the answer, it just takes you an extra step. In other words, I got to here, and then of course I've worked with square root of 20 so much that I know that that breaks down also into 2 root 5. So I've got 4 times 2 root 5, or 8 root 5. If you divide it immediately by 64, in other words, it's also equal to the square root of 64 times square root of 5. And that gives you 8 root 5 immediately. Okay?
Mm-hmm.
That one was a little tricky. A little trickier, I should say. Okay, let's go on. 94 was that one. This one's 95. Okay. That's all solid geometry today, huh?
Mm-hmm.
Measurement of the diagonal in terms of x. Well, they say AB is equal to x, so let's label that. And AC is equal to x. All right, what are they talking about? That can't be right. I think it's a typo. You see why it can't be? They can't both be x?
Yeah.
First of all, the hypotenuse is always the longest side of a right triangle. And that right triangle, ABC, can't have one side being x and have the diagonal being x. And yet that's what they've told us. So my guess is this means BC equals x, since it's a cube. And a cube has a square as its base. So if that's true, what is AC equal to?
It'd be x.
Square root. When you're solving a right triangle, your answers always, 100% of the time, start out with the words square root of. It could be a number. It could end up being square root of 25, and then it's 5. But always, the shortcut to doing the Pythagorean theorem is to learn this little, skip that first step. In other words, any side of a right triangle is always the square root of something else. In this case, it's the square root of what?
Square root of 3x.
No, it's the sum of the squares of the sides. So this side is x squared plus x squared. Right?
Mm-hmm.
I have a triangle like this, and that's x and that's x. That's the square root of 2x squared. Now, how do I simplify that? Square root of 2x squared. I can simplify that.
Just the square root of 2 and then x on the outside.
Yes. In other words, it's x times square root of 2. And notice that I didn't need the Pythagorean theorem. I know that if that's 1 and that's 1 from my special triangle, this is square root of 2. So adding the x's is a piece of cake. In other words, this is x, that's square root of 2x. Automatically right away. I don't have to go through this step here. Let's see, which one is this? This is, this is 95, okay? Let's blow it up just a little bit more. Wow, I think I told you wrong once before. About, no, maybe not. Not. I think I told you that if this line bisects that angle, then it always creates a right angle up there. And clearly that's not true here. In other words, we can tell that that angle is 30, started out as a 90 degree, so this has to be 60. In other words, SV does not bisect V. And yet it still creates that straight line up there. Yeah, there were a couple of problems, maybe 2 sessions ago, where we had that. And I kept thinking that he'd left out some information. Now I'm having second thoughts on that. Wow, now I really can't figure out how to solve those other problems. But this is easier because we know all the angles involved. In fact, notice we are looking at 3 similar triangles. Right? We're looking at 2 for sure that are both 30, 60, 90. And then the big one on the outside is a 30, 60, 90. And when that's what I meant to say before, is when you start with a 30, 60, 90, and you draw a line from the right angle point to the other side, you create 3 similar triangles automatically. If you draw I guess that's called an altitude. SV would be an altitude for triangle TRV. All right, so using the figure, fine. The only side we know is this 6. So let's start labeling sides. This is a 30, 60. We know that opposite the 30 is half the hypotenuse, right?
So that'd be 3.
So that's 3.
And then you just multiply it by square root 3. So it'd be 3 square root 3.
Okay. And now, let's see, they want VS, which we've just given them, 3 square root of 3. And they want ST, this dimension right there. Well, we can figure out TR, I think. Yeah, what's TR?
TR.
Based on our 30/60.
It's going to be 11 square root 3.
I think it's 6. In other words, it's always this number. Notice that if I draw your standard one, the side opposite the 30 degrees is always 1. Hypotenuse is always 2, and this is always root 3. Okay? So I was wrong. The whole hypotenuse is 12. Got to be twice 6. So TR is 12, which makes TS
9.
And in VT, we now have a triangle whose dimensions are 12, 6, and they want this bottom side. What is that bottom side going to be?
6 square root 3.
Yeah. The ratio of the perimeter of VSR to the perimeter of VRT. That's probably an easy way to do this, but let's just do it the hard way. What's the perimeter of VSR?
That'd be 9, 12 square root 3.
No, it's this. This is how you write it. In other words, it's 3 plus 6, that's 9, plus this dimension is 3 root 3. Okay? So that's this triangle. That's the perimeter of that triangle. They want the ratio, so we need the perimeter of the outside triangle. What's the perimeter of the outside triangle?
12 plus 6 plus 6 square root 3.
So that's 18 plus 6 square root 3. Now, can I simplify that?
Yes.
Yeah, I can divide top and bottom. In other words, how do I simplify that?
It would be 1 over 2, because 9 times 2 equals 18.
Believe it or not, I don't think that's correct. First of all, what we have to do, we cannot combine those two numbers. 9 plus 3 root 3. We cannot combine them unless we convert it to a decimal. We're not going to do that. Okay? So right off the get-go, it looks like the numerator is exactly half the denominator. So I'm thinking that should go to 1 over 2. But how do I get there? Well, it's really rather simple. You divide the top by 9 plus 3 root 3, and you divide the bottom by 9 plus 3 root 3. That gives you 1 in the top, and it gives you, now if I take this bottom, and I can't divide everything by 9, I can divide everything by 3, which gives me 6 plus 2, 3 plus 1, 6 plus 2 root 3, all over 3 plus 1 root 3. Got to be 2, doesn't it? How come I can't make it come out to be 2? Actually, I'm not 100% sure it is 2. what is this number? That's 3.4. That's 9.4 divided by 4.7. Yeah, it's 2 for sure. I don't know why I'm having a hard time proving that that's 2 algebraically. Well, it's the same problem as proving our original problem was 1/2. Question is, how do you do that? With this kind of math, it's not as easy as it seems. In other words, 9 plus 6 root 3, if I divide that by 18 plus 12 root 3, it looks clear that the denominator is twice the numerator. Oh, and it is. If I were to multiply the numerator by 2, then I get the denominator. So really, the way to do this problem, I don't know why it was giving me problems, is to take the denominator and take out a greatest common factor, which is 6. So the denominator becomes 6 times 3 plus 2 root 3. If I do the same thing to the numerator, I take out a, oh boy, you get the picture.
Yeah.
I can make this exactly half of that. There's going to be a 3 outside there, and then what's left over is 3 plus 2 root 3. The 3's plus 2 root 3's cancels, and I'm left with 3 over 6. All right. Weird. I never realized that that was kind of a problematic thing to do. It's not really. It's just the way I was looking at it. Okay. One of the angles of a rhombus has a measure of 120 degrees. If the perimeter, you haven't learned about radians yet, have you?
No.
Okay.
We don't have to do this problem.
We don't have to do 18?
Yeah.
Okay. What's the next thing we need to do?
19.
Fine.
And then 21.
And then 21?
Yeah.
Okay. So the perimeter of the trapezoid is going to require us to figure out this side and this side. How are we going to do that?
You can make the end a triangle.
Yeah, that's exactly right. And now we know that's 10. I know that's 8. That's a 30-60. Opposite the 30 is 8. Therefore, what's the hypotenuse?
16.
And what is this little segment?
8 root 3.
Uh-huh. You've actually picked up on that better than most any student I've ever had on how to solve these 30-60 triangles quickly without having to go through the Pythagorean Theorem. Okay? So my perimeter is going to be 8 plus 10 plus 16 plus that plus that. And I'm not going to worry about a number because they want you to come up to the nearest tenth.
Mm-hmm.
In case you're wondering, when I have an expression like this, that cannot be simplified. That is a number. Okay? So in reality, if they didn't ask us to do it to the nearest tenth, I would have 8 plus 10 plus 8 plus, plus another 10 plus 16 plus 8 root 3. That's my answer, and I can combine all the numbers. They all combine to 34. So the true answer here is 34 plus 8 root 3. That would be what a mathematician would want to see as an answer. They never want to see rounded off. Now, it's a little bit different if I'm building a garden, okay? And I'm building a garden and I need these dimensions and I got to go out and measure it with a ruler. Well, then I'm going to round it off to a number. I don't have any way on my ruler to do square root of 3. So problems like that, for sure, you round it to the nearest tenth or hundredth or whatever. But from a pure mathematician's point of view, you don't round them.
Mm-hmm.
Usually it's somewhere in geometry where they make the switch over, where they stop having you represented as a number. When you take algebra 2, they won't have you round anything. They'll say leave all your answers in radical format or pi format, you know. Okay, let's look at 21. Any octagon can be divided into rectangles and right triangles as so. Okay. Here's the side of a central square is 6 units long. Okay, that's labeled. Find the perimeter of the octagon.
So wouldn't it just be
Well, we know
6?
that's 6. We know that's 6. We know that's 6. And we know that's 6. So if we
So
can
it'd be
find
20.
one diagonal,
Well,
what's this distance right here?
that's going to be 6.
Yes, even though they've not drawn it that way. They have not drawn it to scale. That looks shorter than 6 to me, doesn't it to you?
Yeah. So wouldn't it be a 45, 45, 90? So it'd just be 6 root 2.
Beautiful. Now, how many of those do you got?
4.
So it's 24 root 2 for all your diagonal ends plus 24 for these 6 parts. So that's the perimeter. And here they did not ask you to round it off. So the correct answer is 24 plus 24 root 24. Root 24 or root 2?
I think it's root 2.
Root 2. Yeah, all of a sudden the number of 24s I was getting seemed unlikely. I wrote it wrong. So that's the answer.
Mm-hmm.
Find the span of the octagon.
What's the span?
Well, that's what I was just going to ask you. Let's see. That's 2.
It's labeled on the outside.
Huh.
So it's the height of that, right?
Yeah, but now I'm not as convinced that these are 6. Merely because they're drawing doesn't make it look like it.
They do that a lot, though.
I know. I'm just trying to figure out whether we can prove it or not. In other words, it's a regular octagon. So, we got problems here. A regular octagon, every measurement, yeah, we did this wrong. They actually did draw it to scale. That's 6. Regular octagon are 6 equal sides. So what's the perimeter?
So the perimeter would be 48.
Yeah, the perimeter is 48. 6 times 8. And that's why that doesn't look to be 6, because it isn't. Find the span. Okay, so what we need is this distance right here. Well, that is a 45, 45. So what is that distance? Going backwards. This is where that method gets a little bit tricky. Here I'm going to draw my regular 45, 45. Now, how do you compare this triangle right here to this triangle? What's the similarity ratio?
1 to root 2.
No. Use the two corresponding sides that you know of. This one's root 2, this one's 6. Go big to little.
6 to root 2.
That's the similarity ratio. In other words, I've taken the hypotenuse of this versus the hypotenuse of this. Okay? So this is the same ratio that all of these sides have to have. So instead of a 1 here, what is that?
It's a root 2.
It's 6 root 2. In other words, I'm taking this my similarity ratio. I'm taking the similarity ratio and I'm going to multiply it by 1 to get that side. And this side over here is also 6 divided by root 2. There's only one problem with that answer. What is it?
One problem?
Yeah. You're not supposed to put irrational numbers in the denominator.
Oh, so just multiply it by root 2.
Top and bottom. So you get 6 root 2 there, you get 2 root 2 there, and then it simplifies to 3 root 2. So instead of 6 divided by root 2, that's actually 3 root 2. Both that one. So that's 3 root 2. That's 6. And that's 3 root 2. So what's the span?
6 root 2 plus 6.
Correct. Or 6 plus 6 root 2. I usually put the irrational part second when I have to write something like that. All right. Okay, this is 396. That was that one. And we've got a 391 that we never did open. 1, 2, 3, 4, 5, 6. This is the only one we haven't looked at. We got about 4 minutes. And unfortunately, we don't even have 4 minutes. I do have a 4:30 to go to. Let's see if we can find the altitude of this real quickly. I'm sure you can do it in less than 3 minutes. Whoops. At least if I don't slow you down. My screen sketcher is out of action for the moment. No, it isn't. Here it comes. All right. So the first thing we're going to do is draw the altitude. It's an isosceles triangle, so we know that creates 2 congruent triangles. And the altitude to the base. So if we can figure out this, find the altitude. We just need to figure out the altitude. So let's look at this triangle right on the left. What kind of triangle is that?
That's a right triangle, so 45, 45, 90.
Hold on. We're bisecting that 120-degree angle, so that's got to be 60. So this is going to be a 30-60 triangle. And this side is 9. So what is the altitude?
The altitude would be 3 root 3.
Well, that's a little tricky. This is a little hard for me. If I draw the normal one, there's the 30. That's 1. That's root 3. That's 2. Okay. So what is the relationship between this triangle up top and this triangle down there? What's the similarity ratio?
9 to square root 3.
9 divided by square root of 3. That's the similarity ratio. In other words, every side over up top is going to be that ratio times this. Well, it's times 1, right? So this is going to be 9 over root 3. Rationalize it. What do you get?
You get 3 root 3.
Yeah. But you came up with awfully quickly. How did you come up with that so quickly? Did you go through all these steps?
No, I'm good with square roots.
You are. Oh, you didn't do the Pythagorean theorem. You just used the similarity, but you did it a little differently.
Yeah.
Okay. All right. Joseph, I will let you go and talk to you next time.
You too. Have a nice night.